let's get started. Today, in our last lesson, we were drawing graphs using given equations. Today, we will be figuring out the equations of graphs using points on a graph. Okay, now a few things that I feel like I need to remind you guys is a general formula that we use to find those equations is y equals mx plus c. We've already seen this. Someone remind me what m is. Please remind me what m is. Thank you very much, Kwezi. Kwezi is awake and ready to learn. And so is Abukan. Beautiful. M represents our gradient. Who remembers what C represents? Oh, Komoto, it's your y-intercept. So we remember. Now, C is the y-intercept, but there's another method we can use to find C. Does anyone remember what that method is called? How else do we find C? We can just look at the y-intercept and find it, but there's another way that we can use to find C. Does anyone remember what that way is? Anybody? It is a constant, yes, Lerato. But let's say we're given a graph and we want to figure it out. We use substitution. We forgot. Yes, Havana. I hope Havana wasn't going to say substitution because I said it's substitution. English is not, it's not a thing for me, guys. This is why I teach maths. Substitution. Yes. Okay. Now, let us find the equation of the graph that is on your screen right now. We have 2 points. Our 2 points are 2 and 3. Maybe I should name them. Okay, point A and point B. So first things first, we need, how can I say substitution? Okay, we need to use our points to A, find the gradient, and then B, find C, and then we'll have an equation. Okay, so what is our formula for our gradient? Yes, Fatima. Fatima? You can unmute.
Hello, ma'am.
There you go. Hello.
How are you, ma'am?
Good, and you?
I'm fine, ma'am. Ma'am, our formula is m equals to y1 minus y2 divided by x2 minus 1 over x1.
X1 minus X2. Remember, they have to be in the same order.
Oh, yeah. But ma'am,
Okay.
does it still come? Will you get your answer the same?
No, if you swap them around, you won't get the same answer. Okay.
Yes.
So which one are we choosing to be 1? A or B?
A.
A. Okay, let's substitute, Fatima.
So you're gonna write 3 minus -1, but you put -1 in a bracket, yes. Divide by 2 minus 0.
Nice. What do these negatives do? These two negatives.
They cancel each other, man.
They become a
positive.
There we go. And then, so it's going to be what over what?
It's good. The answer is going to end up being 2, man.
Beautiful, Fatima. 4 over 2, which is 2. We have M. Beautiful. Thanks, Fatima, for getting us started. Okay. Who wants to work out C with me? Okay, well, we can just look at it. What is C? Does anybody know what C is? We're going to do both methods. We're first going to do it by observation. That would be correct, Abukan. Abukan says C is equal to -1, and anyone who's confused is because Abukan looked at the y-intercept, which is -1. So 2 methods, either by inspection. So then it's going to be -1. I don't know why I wrote C, Y. Or let's do it by formula. Let's say you're not comfortable with that looking thing. You don't like looking at the graph. Okay, you're going to have y equals, we just worked out that our gradient is 2x plus c. Now we're going to use a random point. I choose to use 2, 3. So I'm going to use this point over here that I just wrote over for some reason. Okay. This point over here. Okay. That point is 2, 3. Remember, wherever I see a x, I must put 2. And wherever I see a y, I must put 3. Okay. So then you're going to have 3 is equal to 2 times 2 plus c. What's 2 times 2, guys? What's 2 times 2? There we go. 4 plus c. When it goes over, this 4 becomes... Why am I getting a different answer? Wait. We got... Oh, it's the same answer. Never mind. 3 becomes a -4 equals c. Therefore, c is -1. So we've done the y-intercept method and the substitution method. So now, finally, we need to answer the question, guys. The question was, what is the equation of this graph? It is y equals 2x minus 1. Beautiful. I saw someone say they're confused. No, Sisa, put your hand up. Please tell me where I confused you. Let's hear what No Sisa has to say. Everyone else, thumbs up, thumbs down on the ways to find y-intercept. Yes, No Sisa.
Hi, ma'am.
Hello.
So, ma'am, I was asking about the second parts because I understood the first parts, like the first half.
Did you understand the gradient part? Let's do a checklist.
Yes, I did.
Okay. Now, Nosisa, we take the gradient that we just found here. We found that the gradient is 2, right?
Yes.
And we put it into our formula. Okay.
Yes. Substituting.
Now, yes, now we have C left, and we want to know what C is. So you need to take a random point on the graph. Now I chose 2 and 3. You see?
Yes.
Now I'm going to substitute again 2 where there's an x and 3 where there's y, because that's how we write coordinates. We write the x and then the y. Do you agree?
Yes.
So I substituted, look over here. I substituted 3 where there was y, and I substituted 2 where there was an x. You get it?
Yes.
So then I multiplied 2 times 2 gave me 4. Now I want C to be on its own. And in order for me to do that, I need to take 4 over the equal sign to the other side. What happens when it goes over the equal sign?
It becomes a negative.
There we go. Now we have 3 minus 4. What's 3 minus 4?
-1.
There we go. Did I find you?
Yes, ma'am.
Beautiful, Nosisa. Brilliant. I love it. Okay. Nosisa feels better. Everyone else? Is there anyone else who wants any explanation? It's okay, Palisa. Welcome. Anyone else? Are we good? So, there we go. Nosipo. Yes, Nosipo.
Ma'am, at my school, we say y2 minus y1 instead of y1 minus y2. Does it give you the same answer?
Yes. The only thing,
okay.
Nosipo, is they have to be in the same order. You say y2 first, right?
Yes.
But then you have to say x2 first.
Yes.
There we go. So the only thing is they have to be in the same order. Otherwise, it doesn't matter. Even if you swap them around, it will give you the same answer, okay?
Okay. Thank you, ma'am.
You're welcome. Okay. One more call for questions. No, nope, no was done. Okay, let's do some more of these. This is the last of everything. I feel like this feels easy because we started off with doing individual aspects of everything. Like we first did substitution, and then we did the gradients on its own. Then we did finding C on its own. All we're doing now is putting everything together. Okay, guys. So let's see if we can put everything together. That depends on the question, Lerato, okay? I just substituted. So if I ask you, what is the gradient? Then you have to say m equals 2, or the gradient is 2, okay? But if the teacher asks you, what is the equation for this graph? Or what is the formula for this graph? Then it's okay to just substitute. Okay. There we go. Let's go. Next one. It's okay, Sophie, welcome. There we go. Here's our next one. Here's our next one. Okay. First things first, writing the general formula. Y equals mx plus c. We want m, we want c. Let's go. Who's doing m and c with me? Who's doing M and C with me? Before we do M and C, let's identify some few points in the previous, and I gave you coordinates to work with. But when you have a random graph like this, you're gonna have to pick coordinates, okay? So, yes, Tammy?
Hi, ma'am.
Hello.
How are you, ma'am?
I'm good. Brilliant mark, by the way. I won't tell everyone, but
Thank you, ma'am.
great. Are you gonna do this with me?
Yes, please.
Okay, let's hear.
Okay, ma'am. So then, the coordinates I'm going to choose, I'm going to choose 0 and 6 for the y-intercept, and then 2 and 0 for the x-intercept.
Beautiful. Okay.
Okay, ma'am. So first we're going to say y2 minus y1 over x2 minus xy.
I was wondering why it's so thick. I'm using a marker. There we go. Whew. Okay, let's go.
And then, ma'am, I'm going to use 6 and 0. So we're going to say 6 minus 0 over 0 minus 2.
Mhm.
And then we're going to 6 over negative 2. Therefore, gradient is equal to negative 3.
Wonderful. Okay, are we going to find C together?
Yes, ma'am.
Are you going to use the graph, or you want to work it out?
Ma'am, we can use the graph.
Okay.
No, ma'am, actually, we can work it out.
Okay, so let me write down then. Therefore, y is negative 3x plus c. Let's work it out. Which point are you going to use to work it out?
Ma'am, I'll use 2 and 0.
Okay, we're going to use the point 2, 0. Let's substitute.
Okay, ma'am, so we can, we're going to write 2 is equals to negative.
Be
Oh, wait,
careful.
sorry. 0 is equals to negative 3 in brackets 2 plus c.
See?
And 0 is equals to negative 6 plus c.
Mhm.
And then we're going to transpose the 6 to the left hand side. So we're going to say that 0 plus 6 equals to c. And c is equals to 6.
Beautiful. So what's my equation? Y equals?
Negative 3x plus c plus 6.
Beautiful, Tammy. Thank you very much. Thank you very much. Guys, we can even compare with the graph, okay? after you get the c is equal to 6, you look on your graph. Is my y-intercept 6? Indeed it is, and that would be correct. Woo. Okay, ma'am, what if you swap around the coordinates? Fatima, it doesn't matter. You just need to use the same coordinate first and the same one second. Okay. Hi, Oya. I see hands going up. Sinesihle, do you have a question? Sinesihle, you may unmute. No.
Hi, ma'am. I wanted to answer the third one.
Ah, Sinesihle hasn't even seen it, but she's like, I want to answer it. I don't care. Okay, Sinesihle, let's go. Let's go on to the third one. Okay. There's my third graph. You ready?
Yes, ma'am.
Let's go for it.
So, ma'am, the x axis would be 6 and 0,
Mm-hmm.
and then the y axis would be negative 2 and 0.
Remember, it's the intercept. Oh, but you need to look carefully. Is it at 6? This graph is a bit small. Should I zoom in?
Yeah. So well, that would be 6.5 and 0.
Yes.
6.5 and 0.
So this is 6,5 and 0. And your y-intercept?
It would be 0 and negative 2.
0 and negative 2. Beautiful. Remember, you're allowed to use any other point, okay?
Yes,
Like
ma'am.
if you're in a test and you find something like this, you're allowed to find a point that you can see better. But this
Yes,
is
ma'am.
fine. There we go. Okay, let's go for it.
And then our formula would be m is equal to y1 minus y2 over x1 minus x2.
X1 minus X2. Okay, let's substitute.
So it would be for y1, it would be 6.5.
That's the X. Look carefully.
That's
Which
the
one
x.
is
So
one?
so ma'am, that would be negative 2
Mm-hmm.
multiplied by 0
Minus, remember we're subtracting.
minus 0, ma'am,
Mm-hmm. And then,
over 6.5.
nope, they have to be the same coordinate. So if
0
you,
minus 6.5.
there we go. So if you use this one first, we have to use it first for both. Over 0 minus 6,5 equals. Mm-hmm.
And then ma'am would say negative 2 minus 0, that would be negative 2 still, over 0 minus 6.5, that's negative 6.5.
Mm-hmm.
And then we divide negative 2 over negative 6.5. Our answer would be, our answer would be 4 over 13.
Okay, 4 over 13. Okay, that's
Yes.
our M. How do you
Yes,
want to
ma'am.
find C? Do you want to look on the graph?
Yes,
do you
ma'am, I'll
wanna-
try it.
Let's find C. What is C again?
So ma'am, C is the y-intercept.
There we go. And you said the y-intercept was what?
0 and negative 2.
So therefore C is how much?
C is 2x.
It's negative 2.
Negative
Remember?
2x.
So it is your y coordinate of
Y
the
coordinate.
y-axis. Okay, let's work. Let's substitute. Therefore, my equation is y equals
Negative 2.
let's start with the gradient.
Oh, that's, oh, y is, so must I do the gradient, ma'am, or the
Yeah.
intercept?
The gradient first. Remember, it's mx plus c.
Okay, so it will be negative 2 plus 4 over 13.
There we go. 4 over 13x minus 2. Thank you very much, Sinesihle. Okay, guys, I am hoping we are all sort of understanding this. Chief, do you have a question?
Hi, ma'am.
Mm-hmm.
No, ma'am. At the beginning, ma'am, I wanted to ask, how would you determine the coordinates before calculating?
You look at the graph. Do you see the graphs have number lines?
Yes.
So you look at coordinates. This is halfway between 6 and 7. So that has to be 6.5. Do you see?
Yes.
That's where we got the 6,5. And it's a 0 because it is on the x-axis. Remember, anything that's on the x-axis will have a 0 coordinate for y. But, Chief, if let's say you decided to use a different coordinate, let's say you use the coordinate like all the way over here for your calculation, okay? You will get the exact same answers.
Okay. All
Okay,
right. Thank you, ma'am.
you're welcome. Okay, Tabang.
Hi, ma'am.
Hello.
Hi, ma'am.
Hello.
Hello.
Yes, I can hear you.
How are you, ma'am?
I'm good, and you?
I'm good. Ma'am, I would like to answer the next one.
Oh, guys, we
Yes.
are on fire. Okay, Tabang, don't put your hand down. Let me just check people who are asking questions in the chat, okay?
Okay, ma'am.
So that they are not lost and they can sort of follow in the next one. Okay, don't put your hand down. Okay, someone says, how did you get 6,5? Okay, look. It is where, there. It is halfway between 6 and 7. Okay, so this block is divided into 1, 2, 3, 4, 5. So if you're exactly in the middle of 6 and 7, that has to be 6.5. Oh, someone asked me to do the other method to find C. Let's do that. So we had, let me move my graph this way so I can have space. So in the other method, I don't know why I don't just give up with this whole trying to draw a straight line thing. That's not working. So we had y equals 4 over 13 x plus c. I'm going to choose the point, not 6.5 and 0. Let's choose a different point. 0 and negative, excuse me, and -2. So I'm going to use the point 0, -2. Let's substitute. My y is -2 equals 4 over 13 times x, which is 0, plus c. What is anything times 0? Anything times 0 is? Yes, Abu Khan. There we go. Plus c, therefore c is -2. Ma'am, why don't we find x? Why do you want to find x? We want the equation of the graph, remember? Narisha says, where do we get 4 over 3? We did a calculation for the gradient. Narisha, look over here. The y's for one coordinate. The y for one coordinate minus the y for the other coordinate divided by the x coordinates. And then we did a whole calculation. Okay. So if you wanted to leave it here, you could have said 2 over 6,5. That is the same thing, they're equivalent fractions. But if you use the calculator, you probably got a decimal answer, and that is correct. Okay, that's okay. Just make sure you round off properly. Okay. I'm hoping, let me see who asked me to do the other method. Goenga, I hope that's fine. I hope you can see how we got that. Okay. I see hands. I don't know if there are questions. Palesa, do you have a question?
Yes, ma'am. Sorry, ma'am. I
Okay.
came in a bit late, so my mom to find the ingredients, but then where did you get the
The negative? In the chat, please
Ma'am,
ask. Oh, the negative what?
2.
Which one? From C.
Yes.
Okay, Palisa, first we looked at the graph. Remember, C is the same as the y-intercept. So there's the y-intercept. Do you agree?
Yes, ma'am.
So what's the coordinate for the y-intercept? It's -2. Do you see that?
Yes, ma'am. Mm-hmm.
But there's another way to do it, which is here. So remember we found our gradient to be 4/13.
Yes.
Now we have y equals 4/13x plus c. So we substitute a random point. So wherever you see
Okay.
an x, yes, you put a 0. Wherever you see a y, you put a -2 and worked it out. So there are two ways. Okay.
Okay. Thank
There
you,
we go.
ma'am.
You're welcome. Okay, Sanele, do you have a question? Tabang's probably like, I'm going to change my mind.
Hi, ma'am.
Hello, Sanele.
Ma'am, I wanted to ask a question about calculating. Don't we like use both of them because like there's a or B, whatever letter you give the coordinates.
Don't we use all of them? What do you mean?
Ish, ma'am, like okay, let's say okay, the 6,520, we name it B, and then the 0, yeah, 0,-2, we name it A. Then we say Y. Yeah. Ish.
Okay, we just didn't name them. Let me show you. If we had named them, this equation is just telling you, take the y from coordinate number 1, whichever that is, minus the y from coordinate number 2. But do you get what I did here?
Yes, ma'am.
So it depends. We're just naming it. So mathematics is like, you're just telling people what you're doing. So if the coordinates are named, then you have to use the names. So you must tell them that I'm taking the y of A and subtracting the y of B. And then at the bottom, I'm taking the x of A, subtracting the x of B. That's why a lot of them differ. Like in some schools, it's 2 minus 1. Some schools, it's letters. In some schools, it's 1 minus 2. You're just telling people what you're doing. Okay.
Oh, yeah. Thank you, ma'am.
You're welcome. Okay. Nokubonga.
Hello, ma'am.
Hello.
Ma'am, I just have a quick question. Ma'am, the 4/13 is our gradient.
Mm-hmm.
Oh, okay, ma'am. I just wanted to make sure because, ma'am, you confused me when you did the formula y equals to mx subtract c, which is y equals to 4/13x subtract 2.
Yeah, but that's only because the gradient was negative. We worked out the gradient to be negative. Okay. It's mx
Ma'am,
plus c. Mm-hmm.
ma'am, how, ma'am?
What do you mean how?
How
There's a
did you
c.
work out the gradient?
Here's the formula. We took the y of coordinate A. Look at coordinate A. There it is, the yellow one. Y of coordinate A minus the y of coordinate B, which is that one, divided by the x of coordinate A minus the x of coordinate B. It's a formula that we have to learn. Okay.
Okay, ma'am. Then the 4/13 is therefore equals to -2.
No, these are two different things. This is M and this is C.
Okay, ma'am.
So M is 4/13, but C is -2. So they're two different variables. The M is a gradient and your C is your constant.
Oh, okay, ma'am. Now I understand. Thank you, ma'am.
Mhm. You're welcome. Okay, Tabang is probably itching to do the next one. Tabang, are you ready?
Yes, ma'am.
Oh, geez, it's a brain break. You'll do the one after the brain break. Don't go though. I want you to
Okay.
tell me, Tabang, would you rather live without a microwave or without a kettle?
Without a kettle.
Without a kettle, how are you gonna boil water? You guys love food.
We got pots, ma'am. For that.
Yay! Imagine thinking goes like, I will
Ma'am, but
form
the
kettle.
the gas is faster, ma'am, when you're
That's
boiling.
true. But not
Yes.
everyone has gas.
Oh,
Mm.
yes.
Yo, in the guys, stop boiling what's in the microwave. You guys are the second people to say this. Yes, your faces are gonna explode. Yay. Your faces are going to explode, guys. That water, when you open that microwave, it's just gonna go poof. I can't believe it can't be. Yeah, okay. Sure, guys. Let's see. Microwave. See, I'm trying to say they would rather live without a microwave. Okay. Tandalo too.
Hi, ma'am.
Tandalo, would you rather own a restaurant or a clothing store?
I would rather own a restaurant.
You guys like food, Tandalo too. I keep saying. Guys like food. Today, the Would You Rathers are all about foodies. And you guys are all like, Sia says clothing store. I wonder why Sia says clothing. I'm so curious to hear why Sia is saying clothing store. Like Sia's just like, nah, I'd rather a clothing store. Let's see if Sia's hand is up. No, it's not. I wanted to hear why Sia would rather own. Sia, food is life, literally and figuratively, but literally mostly. Let's hear what Anya has to say about her question. Sia says, I love clothes, food can wait. Me, I love food too much, guys. Anya? Hello.
Hello, how are you?
I'm good, and you?
Okay.
Anya, would you rather lose your sense of taste or your sense of smell?
Taste.
You would rather... Anya, you just want to eat food and not taste it. That is so depressing.
I mean, if it's expired, then you can still eat it. You won't know. Best before, better after.
Oh my goodness. Oh my goodness. I'm dying right now. At least you won't be a picky eater.
Best before, better after.
You'll just eat for survival. Oh my goodness. Anya's like, look, you don't have to throw food away. Why waste? Just eat everything. We don't care here. Oh my goodness. Can't be gay. Anya, you're dangerous. I'm scared of you after today. You? Guys. Okay, let's see. Would you rather go to any restaurant for free forever or go to any theme park for free forever? Hello?
Hi, ma'am.
Hello.
Ma'am, I would rather go to any restaurant for free.
You guys don't want to go to theme parks? Guys.
It's about food. What theme park can wait?
Guys, you can go to Disney for free. Do you understand? That you can just go to Disney.
Ma'am,
Disney
it's only
World.
like...
So you don't want to wake up and say, today I'm going to Sunset and just walk in.
No, I'd rather go to a fancy
You
restaurant.
guys like food. Oh my gosh. Oh my gosh. You guys love food. I can't believe this. I feel like I'm catering to foodies today. You guys are all like, yeah. I know today's the day. Okay, that's the end of our brain break. We are doing special graphs now. Let's all have a stretch, drink water. I feel like I've been talking a lot. My mouth is dry. Let's hope I don't drown myself again with my bottle of water. Okay. I hope you guys already have some water. Okay. And you have stretched. Okay. Cool. Let's go. Who was helping me? Tabang. I think it was Tabang. Don't worry, you're not doing anything weird, Tabang. Okay. We're still looking for just the gradients this time. Hi, Tabang.
Hi, ma'am.
So I need the gradients of both those graphs. Are you keen to help me?
Yeah, sure.
Okay, let's go for it.
Why
Maybe I
not?
should maybe
Ma'am.
there we go.
Oh, okay. So let's do maybe A
Okay.
and A. So we're gonna use the formula M is equals to y1 minus y2 divided by x1 minus x2.
Okay.
Y1 is gonna be 5
Okay.
minus bracket minus 0.7 divided by minus 1 minus bracket minus 2.9.
And then
Let me
these two minuses are going to make what? These ones.
positive.
Yeah. So it's going to be 5 plus 0.7 over -1 plus 2.9. Okay. Then
Yes,
how
ma'am.
much is this?
Ma'am, should we like add them first before we divide them?
Yes. Yes, let's add them first.
Okay, so it's gonna be 5.7 over 1.9.
And this is?
Then it's gonna be 3.
Here we go. So we have gradient number 1. Now let's do the one for B.
B. Okay, so use the same formula. M is equals to y1 minus y2 over x1 minus x2. Substitute. So we're gonna say 6 minus bracket 5.3 over 2 minus bracket minus 1.8.
Okay.
Then we're gonna the minus and minus, we're gonna make a positive.
2 plus 1.8. Okay. Then I'm gonna continue here.
Then when we add y and y,
Go and get
is 11.3
divided by
3.8.
And when you divide them, what do you get?
I get, ma'am, it will be a fraction.
Are you
Should I
sure?
put it as a fraction or should I make it a decimal?
Let's say 11,3 divided by 3,8 and tell me what answer you get.
Okay,
Let me see. I'm also going to do it.
0.3. Ma'am, ma'am, on the calculator it says 2.97.
97. If we round this off to a whole number, what is it going to give us?
3.
There we go. Thanks, Tabang. That's what I needed. Now we're
Okay.
going to have a discussion. Okay, guys. So I want to ask you guys, what are parallel lines? Now I'm already introducing what we're doing next week. What are parallel lines? Lines that will never cross or meet. So I need you guys to write this down. Two graphs that are parallel, so I'm telling you these graphs are parallel, will have the same gradient. The reason this was 2 comma something is because these points were probably rounded off, okay? But it's generally the same gradient. So look at there, we have a 3, we have a 3. So that tells us these two graphs are parallel. Now you guys will probably asking, why would we need to know that? Two lines that are parallel, Lerato, have the same gradient. Do you see we did the gradient formula? We got to 3. So that means these lines will never cross. Like there's never a point where these lines will, you know, cross anyway. So these lines can go on forever and ever and ever and ever, and they will be the same distance apart forever and ever. The reason I'm telling you this is if I give you a graph that says y equals 5x plus 1, and I say to you, I have a second graph here that is parallel to number 1. Maybe I should number them. I have a second graph that is parallel to number 1. What will the gradient of that line be? Let's see if we understand what I told you. Teachers love asking this question, so I have to bring it up. It will be 5. So I'm telling you so that you don't get shocked if you see it in a test, okay? So let's write it down. Parallel graphs have the same gradient. There we go. Okay, so parallel lines have the same gradient. Therefore, number 2 will then be y equals 5x plus 4. Okay. What do you mean why? It's because of the spacing. Okay, they will always be the same space apart. So unfortunately here I didn't put a point that was, and I didn't put grids. We would actually check if I had grid. Okay. What is Ropafatsa? Please raise your hand so that we can discuss your question. Where does the 5 and 4 come from? Okay, there's a lot going on in the chat. Ropafatsa,
Hi, ma'am.
these are two different equations, Ropafatsa. They are made up equations. So this is equation 1, and this is equation 2. Okay.
Yes, ma'am.
So I'm telling you that parallel graphs, have the same gradient. So if I gave you this equation, I'm giving you the equation 5x plus 1. Then I'm saying to you, equation number 2 is parallel to equation number 1. So what does the gradient have to be?
The same.
The same. So if the gradient for number 1 is 5, then the gradient for number 2 will also be
5.
You get it.
Oh, okay, ma'am.
Okay. The more you go over it, guys, the more we will understand. Yes, Tabang? Tabang? I made it up, Nosisa. This is just an equation that I just made up. I'm telling you that it is mx plus 4 because I want to emphasize the fact that the m will be equal. Okay, don't look at 4 and 1 right now. We're focusing on m. Do you understand, Nosisa? The point here was to emphasize that parallel lines will always have the same gradient. Yes, only the m will be equal. That plus 1 and plus 4 don't have to be equal. Only m, which is gradient, will be equal. Beautiful. Okay. Are we good? I think that is an information overload. Time for the quiz. This was just enrichment, guys. Okay. This is for people who are going for those distinctions. This is information that we need. I want you guys to go and find out. Actually, let me give you guys homework. It's not going to be hectic. You're just finding out. Just Google when you have chance. Go and find out the relationship between the gradients of perpendicular lines. So we did the gradient of parallel lines. I want to know the gradient of the perpendicular lines. How do they relate?